Hello students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. Okay, I hope I'm perfectly audible and visible to each and everyone present over here. Hi Arush, good evening. I hope I'm audible. Not visible? Hi students. Okay, fine. I hope I'm audible now. Arush, can you please confirm if I'm audible or not? So we can start our session. We are moving to, okay, thanks for the confirmation. So we are going to, extremely sorry for the delay that has happened here. So we are moving to our new chapter, chemical bonding here. So this is a new chapter which is not from our CBSE syllabus, which is going to discuss in the grade 11 classes in detail, but I'm just giving a brief idea about the chemical bonding chapter. These are the important topics we are going to cover in this class. What do you mean by chemical bonding? What is the definition of chemical bonding? Then we will be seeing about the Kossel and Lewis approach and the Lewis octet rule here. So let's quickly start our session. So what do you mean by chemical bonding? Is there any meaning for the chemical bonding? Something is bonded there, right? So we can just define the chemical bonding as it is the attractive forces, right? Hi, good evening. So this is the attractive force that holds two or more atoms, as we already know. So in a molecule, two or more atoms or ions are forming there, right? So these are combined together by a formation of attractive force is known as the chemical bonding. As you can see over here, right, these are the different atoms. These different atoms are combined together by an electrostatic force. That force of attraction is known as the chemical bonding here, right? Otherwise, we can define the chemical bonding as a phenomenon of the union of two or more atoms involving redistribution of the electrons, such as each atom involved in the bonding acquires a stable electronic configuration. Whenever you are asking about the definition of chemical bonding, you can just give the definition as it is the attractive force. Attractive force that holds two or more atoms in a molecule is called the chemical bonding. Hi Farhan and Arab, good evening. So I hope you understand about the concept of chemical bonding, right? What do you mean by chemical bonding? What is the definition of chemical bonding? Now let us see how they are forming, right? How they are forming, what is the concept behind the chemical bonding here? So in order to explain the definition or the existence of chemical bonding, there is a theory known as the Kossel and Lewis concept. They developed the electronic theory of valence to explain the formation of chemical bonding, right? Formation of chemical bonding between two atoms. So as we already know, what are the different types of chemical bonding? So what are the different types of chemical bonding? Aditya, there is a limitation for me to teach in Hindi. I'm not comfortable with Hindi. So what are the different types of chemical bonding? Okay, I will try to explain maximum clear in English only. As we already know, right, there is two types of chemical bonds are forming, either by the sharing of electrons as well as either by the sharing of electrons as well as the exchanging of electron, right? So there are the two types of bonds are forming. One is the ionic bond and another one is the covalent bond. This ionic bond is formed by the transfer of electrons between atoms or molecules, atoms or ions, right? Then this covalent bond is formed by the sharing of electrons. Let us see in detail about the ionic bond and covalent bond detail in the next class. So as we already seen, what you mean by the what do you mean by the chemical bonding? What are the different types of chemical bonding? Main is ionic bond and covalent bond. We are going to discuss detail about the ionic and covalent bond in the chemical bonding chapter. Metallic bond is also already present there, right? In between two metals, there will be metallic bond is also present. Now, this is the next concept we have to study about the case of Kossel-Lewis approach. There is a Lewis octet rule. Do you have any idea about the octet? The number oct stands for? Any idea what will be the concept behind the octet rule? So oct stands for number of electrons is equal to 8, right? So in order to attain the stability, all the molecules will be attaining stability by gaining 8 electrons, by gaining or losing 8 electrons the valence shell, right? So they will be forming different bonds as well as covalent bond as well as ionic bonds by either sharing or transferring of electrons to get 8 electrons in their valence shell. Such rule is known as the octet rule. That concept is known as the octet concept by Lewis octet rule. So here you can see some points based on the Lewis octet rule. As we already know, we have already studied about the in the case of noble gas, we have already studied about the classification of elements, right? Periodic table we have already seen. In the case of periodic table, we have seen the group 18 elements are the noble gases, right? So in the case of noble gases, all the elements will be except helium, right? Except helium. They are completely ns2 np6 type of electronic configuration. For example, if you are taking the neon, right? So this is the subshell electronic configuration of neon. Neon is belong to the noble gas group or group 18 element. So it will be having a completely ns2 np6 type of electronic configuration, which means that this is their valence shell electron, right? So total it will be having 8 electrons. Except helium, they will be having 8 electrons in their outermost shell or the valence shell. That is simply given here in the sentence. And this type of electronic configuration is called the octet electronic configuration. Is there any doubt about this sentence? And again, in the case of helium, it will be duplet electronic configuration, right? It will be containing only 2 electrons. These are the main important points regarding the Lewis octet rule. In general, octet rule means it will be containing 8 electrons in their valence shell except helium in the case of noble gas configuration. So in general, all the molecules are either sharing or transferring electrons to get stability, to attain stability by giving 8 electrons in their valence shell. It is the basics of the octet rule given here. Again, because of the stable electronic configuration, noble gases have little or no tendency to combine with each other with the atoms of any other element, as we already know, right? There will not be any formation, there will not be any reactivity for the noble gases because of their octet configuration or octet electronic configuration. Here you can see some images, right? I hope you can see the images given here. This is the molecule of CH4 or the methane molecule, right? These dot will be representing the number of valence electrons present in each element. So for example, in the case of carbon, hydrogen, right? CH4 molecule is formed by the sharing of electrons between carbon and hydrogen. As you can see over here, if you are counting the total number of electrons here, it will be attaining 8 electrons in their valence shell, right? So it is obtaining the octet electronic configuration, right? So if you are explaining about the hydrogen or helium case, it will be having the 2 electrons, which is giving the duplet configuration. Arush, please try to revise the periodic table configuration. I have already given how to explain the electronic configuration for the elements, right? Electronic configuration for the elements depending upon the SPDF configuration. Just try to reverse the. If not clear, we will be discussing the next class as a one-shot video for the chapter. So this is again in the case of bromine molecule. Bromine molecule is already having the 7 valence electrons in their 7 valence electron, right? Because they are belong to the group 17 element. So it is easily forming 8 and 8 total, 8 electron in their valence shell. So let us see in detail how we are drawing this structure as a Lewis dot symbol. Okay, this is just basics of the Lewis octet rule, which means that they will be attaining stability or they will be getting stability by getting 8 electrons in their valence shell. It is known as the octet rule. For exception is there for helium or hydrogen, it will be having 2 electrons. So this is a major basic concept behind the Lewis octet rule. Now let us see what you mean by the Lewis dot structure. This is very important when you are going to grade 11 chapter. About the chemical bonding chapter, you need to get an idea about how to draw the Lewis dot structure. So again, Lewis is the American chemist, right? Arush. Lewis is an American chemist, introduced the simple notation to express or represent the valence electrons in an atom. So if you are giving any dot symbol, right? If you are getting any dot in the case of an element, it will be representing their number of valence electrons. This dot is known as the number of valence electrons of the particular atom. This is known as the Lewis dot symbol. Now, what is the significance of Lewis dot symbol? It is simply giving the number of valence electrons, as we already know. Then, from the Lewis dot structure, we can identify their common or group valency of the element. We have already studied in the classification of elements chapter, periodic table chapter. Now, let us see how to draw the structure of Lewis dot structure of different molecules. 4 different rules are given here. Just try to understand from the basics. So let us just read the importance of rule to write down the Lewis dot structure of the molecule. First method or first rule is that calculate the total number of valence electrons. Total number of valence electrons given by a letter T. Here we need to focus that if you are having any element other than hydrogen, you need to give number 8 in the case of total number of valence electrons. No need to worry, we will be explaining in detail about the case of examples. Assuming they are octet, right? For example, if you are getting any of the element, you need to consider that it will be containing 8 valence electrons because they are highly stable, they will be having the octet rule. And exception is again there, if you are having hydrogen, in that particular molecule, you need to give the number of electron as 2, which means that in the case of hydrogen, they are duplet in nature, right? Duplet means they will be containing only 2 electrons in their valence shell. This is the first rule. We need to identify the total number of valence electrons given by the letter T. What about the second rule? Second rule is that we need to find out the total number of valence electrons for the combining atoms. Just identify the difference between these 2 rules. First one, we need to identify the total number of valence electrons in the total molecule. Second one, we need to identify the total number of valence electrons for all the combining atoms, right? Combining atom, which is given by the letter V. Now, in general, if you are trying to identify the Lewis dot structure of molecule, there will be anions or cations are present, right? Anions means they will be having the negative charge. Cations they will be having the positive charge. So, for example, if you are having any of the molecule which has polyatomic anion, for example, I am taking an example of NO3 minus. Total 4 atoms are present, right? NO3 minus. This will be having a negative charge. So, this is an example of polyatomic anion. Aditya, I can understand Hindi, but I am not at all comfortable teaching in Hindi. So this is the example of the polyatomic anion, right? For example, if you are taking the another molecule, NH4 plus, right? Again, it is containing total 5 elements with a positive charge. This is example of polyatomic cation, right? If you are having the polyatomic anion or cation, there is another method to find out the total number of valence electron. If you are having the anion means negative charge, right? So we need to add the unit negative charge to the total valence electrons. And if you are having the polyatomic cation, you need to delete the unit positive charge from the total valence electrons. Let us see in detail from the examples. Then after completing the total number of valence electrons, we need to focus on the total number of bond pair electron. Bond pair of electron means the number of electrons participating in the bond formation, right? So how we can find out the total number of bond pairs? Bond pairs is equal to total number of valence electrons for the molecule minus total number of valence electrons in the case of combining atoms. So you will be getting the number of bond pairs. Then after that we need to find out the total number of lone pairs, right? That will be equal to the total number of valence electrons in the second rule minus total number of bond pair electrons. Then you will get the lone pair of electrons. So I hope you understand the rules to find out the Lewis dot structure. Just take a screenshot or try to make a note over these points. Now let us discuss the Lewis dot structure of different molecules by examples. Priyanka, is there any doubt regarding the rules? Now let us see how we can apply the previous rules in the case of molecules, right? So as we already know, the first molecule I have given here, carbon dioxide molecule. How we can write down the Lewis dot structure of the carbon dioxide molecule, right? So first method or first rule, we need to identify the total number of valence electrons. We are assuming these molecules are containing 8 electrons in their valence shell, right? So here 1 carbon plus 2 oxygen, total 3 atoms are present, right? 3 atoms are present. Okay, Arush, let us see how to apply these rules in the case of molecule. Then you will get an idea. So what is the total number of atoms present here? In the case of carbon dioxide molecule, 1 carbon plus 2 oxygen atom, right? Total 3 atoms are present in the case of carbon dioxide molecule. Now I am assuming they will be containing the 8 electrons in their valence shell. So it will be 3 into 8. That is equal to 24 electrons in their total valence electrons in the total molecule. Is there any doubt? Now we need to identify the total number of valence electrons in the case of combining atoms, right? So what is the... Okay, we are considering the carbon dioxide as a molecule, right? In the case of carbon dioxide, as we already know, what is our first rule? We need to identify the total number of valence electrons by assuming that they are containing the octet, which means each of the atom will be containing 8 electrons, right? So here in the case of carbon dioxide molecule, 1 carbon plus 2 oxygen atoms are present, which means total 3 atoms are present. We are assuming that they are attaining stability by getting 8 electrons in their valence shell. So total 3 atoms into 8, that is equal to 3 into 8, 24 electrons. Arush, is that clear now? Okay. Now let us see how we can identify the total number of valence electrons in the case of combining atoms. So what is that? We are assuming in the case of carbon dioxide, carbon is one of the atom. What is the total number of valence electrons in the case of carbon? What is the valency of carbon or the total number of valence electrons in the case of carbon? For one carbon atom, it is 4, right? So 1 into 4 plus, in the case of oxygen atom, as we already know, atomic number is 8, which means they are containing 6 valence electrons, right? 6 valence electrons. So here total 2 oxygen atoms are present, so it will be 2 into 6. So total it is equal to 16 electron. Is that clear now? First step, we need to identify the total number of electrons, assuming that they are containing 8 electrons or octet rule. So 3 into 8, 24. Then we need to identify the total number of valence electrons in the case of combining atoms. In the case of carbon dioxide molecule, carbon and oxygen are the atoms here. So one carbon atom, it will be containing 4 valence electrons, that is 1 into 4. Then for 2 oxygen atom, it is containing 2 into 6, 12 valence electrons. So total 12 plus 4 is equal to 16 electron. Now what is our next step? We need to identify the total number of bond pairs, right? Total number of bond pairs is equal to total valence electrons of the molecule minus total number of valence electrons in the case of combining atoms. That is equal to 24 minus 16. It is 8 electron, right? 8 electron. So it is forming 4 bond pairs in one bond. If you are giving one bond, it is represented by the 2 electrons, right? So if you are having total 8 electrons, it is represented that it is containing 4 bond pairs. The last step, we need to find out the lone pair of electrons, right? Lone pairs. The lone pairs is equal to V minus bond pairs, right? V minus bond pair. So V is given here 16. 16 minus bond pair is equal to 8. That is again 8, which means 4 lone pairs are also present here. Now let us see how to draw the structure according to Arush, we have already completed the carbon and its compound chapter, right? We have already seen carbon is tetravalent, valency is 4. They will be having the tendency to form 4 bonds with other atoms. They are having the 4 valence electrons. Okay, is there any doubt in these steps? Now we are going to draw the structure of this molecule. So carbon, right? Carbon will be the central atom here. Then oxygen. So what is the total number of bond pairs here? 8 electrons, right? One bond represents 2 electrons. So 8 electrons means they are 4 bond pairs. So drawing total 4 bond pairs, right? Drawing total 4 bond pairs here. Now we need to identify the total number of lone pairs here, right? In the case of carbon, the complete 4 valence electrons are combined here as the 4 bonds. Then the remaining so this will be the structure of carbon dioxide molecule. Is there any doubt? Anyone? So this is the method to write down the Lewis dot structure for the different molecule given here. This is the neutral molecule. There is no any charge, so we can use the different rules here. First rule, we need to identify the total number of electrons, assuming that yes, dots represent the lone pair. And the lines represent the bond pairs given here. Is there any doubt? Okay, now let us see the another example given here, nitrogen molecule. I will just give the different values given here. So what is the total number of electrons here? What is our method? Total number of electrons. Identify the total number of atoms, then multiplying with the value into 8, which means they are attaining 8 electrons, right? So what will be the total number of electrons here? 2 nitrogen atoms are present, right? Aditya, is there any doubt regarding the class? Okay, what is the doubt? I will try to give answer in English. So in the case of nitrogen molecule, right? Nitrogen molecule means they are containing 2 nitrogen atoms. So we know that they are attaining the octet. Octet means 8 electrons. So total number of valence electrons for the molecule will be equal to 2 into 8, that is equal to 16 electrons. Now the second step, we need to identify the total number of valence electrons for the combining atoms, right? Combining atoms. So as we already know, in the case of nitrogen molecule, their atomic number is 7, right? Nitrogen is having atomic number 7 and the electronic configuration is 2, 5, which means the valency of the nitrogen atom is 5, right? 5 means 2 nitrogen atom is present, so 2 into 5, that is equal to 10 here. This is the total number of valence electron. Now our next step is to find out the total number of bond pair. So bond pair is equal to total number of valence electrons minus valence electrons given here. That is 16 minus 10, that is equal to 6 electron, right? 6 electron means 6 by 2, right? One bond representing 2 electrons. So 6 electron means 3 bond pairs, right? 3 bond pairs. Now the lone pair is equal to V minus bond pair. So V is again here 10 minus 6, that is equal to 4 electron or 2 lone pair. Okay, we have already studied about the electron negativity order, right? So the element with more electron negativity will be the central atom here. For example, the case of carbon. So this is the method to find out the bond pair, lone pair and total number of valence electrons in the case of N2 molecule. Now let us see how to draw the structure of this molecule, right? 3 bond pair. As we already know, there is only 2 nitrogen atoms are present. 3 bond pairs are forming, right? 1, 2, 3. Now the remaining electrons will be the lone pairs. So if I am drawing here, there will be one lone pair in the case of one nitrogen atom and another lone pair in the case of another nitrogen atom. So total 3 bond pairs and 2 lone pairs we have already given from the method here. Is there any doubt? Aditya, we have already discussed in the chapter of acid, base and salt, right? Whether they are endothermic or exothermic reaction, just rewatch there. You will get the correct answer there, right? What is happening when we are adding to acid to water or water added to acid, whether it is an endothermic or exothermic reaction. So depending on, you will get an idea about that. Okay, in the case of water, right? So what about the case of water? What is the... Yes, we have already studied the electronegativity order in the case of periodic table chapter, right? It's not about the reactivity, electronegativity is in another order. So in the case of oxygen, in the case of water molecule, oxygen will be the central atom. We need to identify the total number of electrons, right? Total number of electrons is equal to total. Here you need to keep in mind that in the case of hydrogen, we are not assuming there are 8 electrons, it will be 2 electrons. So here it will be 2 into 2 plus 1 into 8. Total 12 electrons, right? Yes. In the case of valence electrons, in the case of hydrogen, there will be 1 valence electron is present, right? So 2 hydrogen is 2 into 1 plus 1 into 6. That is equal to 8 electron. Now we need to identify the total number of bond pairs, right? So that is equal to T minus V, that is 12 minus 8 equal to 4. 4 means 2 bond pairs. Then what about the case of lone pairs? Again V minus bond pairs, right? So V is here 8 electron, bond pair here 4, right? So 8 minus 4 is again 4, which means 2 lone pairs are also present in the case of water molecule. Now what will be the structure of water molecule? Oxygen will be the central atom here. So oxygen, 2 bond pairs for the hydrogen, the remaining 2 will be the lone pairs. So this will be the exact structure of the water molecule. While we are discussing about the hybridization part, you will get an idea about the structure also. Is there any doubt regarding the water molecule? Here is another example in the case of polyatomic cation as well as the polyatomic anion. I will just give a brief idea about the calculation given here. So total number of valence electrons. In total 4 hydrogen plus 1 nitrogen, right? So it will be 1 into 8 plus 4 hydrogen is 4 into 2. While finding the total number of valence electrons in the case of molecule, we don't want to consider about the charge given here. So it will be 8 plus 8, 16, right? So it will be 16 electrons. Then what about the case of total number of valence electrons? For hydrogen it is 1, for nitrogen it is 1 into 5 and for hydrogen is 4 into 1. Here we need to consider the positive charge, right? If you are having the polyatomic cation, you need to divide or you need to take the difference between unit positive charge given here. So this is a V value minus minus 1 is the positive charge given here, right? So total number of electrons will be equal to 5 plus 4, 9 minus 1 is equal to 8 electron. Now the bond pair is equal to total number of electrons minus total number of valence electrons. That is 16 minus 8 is equal to 8. 8 means 4 bond pairs, right? Then the lone pair is equal to V minus bond pair. V is again 8 here. Bond pair is again 8 here, which means that there is no any lone pairs present in the case of NH4 molecule. Now what will be the structure of this molecule? So what will be the structure of this molecule? So as we already know, if you are comparing the electronegativity difference here, nitrogen will be the central metal atom, right? Sorry, central atom here. So nitrogen, total it is forming 4 bonds with the hydrogen atom. So I will draw the structure here. In the case of nitrogen molecule, 4 bond pairs are formed with the 4 hydrogen atom, and the total charge is given by a bracket given here. So this is the structure of NH4 molecule. Now just try to find out the structure of NO3 minus. Just try to identify the structure of NO3 minus molecule. The only difference is that if you want to find out the total number of valence electrons, you need to just add one negative charge to the total number of valence electrons in the case of these NO3 minus molecule. Then you will get a structure like this. So this will be the structure of NO3 minus molecule. Just try to identify the structure by using this molecule. Now here is some practice questions for you. Just try to identify the answer for this question. Which of the following statements best defines a chemical bond? Yes, option B, right? The attractive force that holds atoms or ions together in a molecule is known as the chemical bonding. So based on that, we will be defining about the ionic bond as well as the covalent bond. Here is our next question. According to the Kossel and Lewis approach, atoms combine to form molecules mainly to. What is the exact use of the Lewis octet rule? So what will be the answer for this question? Why the atoms are combined together to form molecules? Yes, attain stability, right? Which means they are decreasing their energy. If you are attaining the stability, which means that they are decreasing their energy. So decrease their energy and attain stability will be the correct answer here. Again, option B is the correct answer. Here is the next question. The electronic configuration that provides maximum stability to an atom is. Again, option B, right? So as we already know, they are attaining stability by gaining or losing electrons, or transferring or sharing electrons to attain 8 electrons in their valence shell. The general electronic configuration is ns2np6, known as the octet configuration. So option B will be the correct answer here. ns2np6. Okay, I hope you understand. Our question is the electronic configuration that provides maximum stability to an atom, which means they are octet. Octet means ns2np6 is the configuration of the noble gases. Okay, here is the next question. Which of the following elements naturally exist as independent atoms under normal conditions? So we have seen one exception in the case of noble gases, right? They have the duplet configuration even though they are stable. Yes, Aditya, you are correct. Option C is the correct answer, right? Helium molecule. Hydrogen. Our question is, which of the following elements naturally exist as independent atoms, which means they are not forming any atomic molecule like diatomic or polyatomic. Helium is simply exists as helium, single monoatomic atom, right? So it will be having 2 electrons, duplet configuration. But in the case of hydrogen, they will be attaining stability by forming H2 molecule or the diatomic molecule. Is that clear, Arvish? Now let us discuss very few previous year questions. Why do atoms combine to form molecules? This is the basics of the chemical bond formation. So just give me a single sentence about the combination of atoms, why they are forming molecules. If you are asking about the single word, answer is to attain stability, right? To attain stability by achieving a lower energy state by forming chemical bonds, atoms can acquire a stable electronic configuration of octet. So this is the main important point. The first point, they are attaining stability by getting 8 electrons in their valence shell by reducing energy, right? So reducing energy, attain stability, and 8 electrons in their valence shell will be the correct answer for this question. Is there any doubt? Okay, here is the next question. State octet rule. In the case of octet rule, we have seen, right, they need to 8 electrons in their valence shell or the outermost shell. So if you are explaining in terms of a complete definition, the octet rule states that atoms tends to combine in such a way that each atom has 8 electrons in the outermost shell or the valence shell to achieve the stable electronic configuration of noble gases. So this is the exact definition of octet rule. Just write it, just keep a note over there. Clear? Okay. That's all about from my side for today. We have just introduced about the chemical bond formation. What do you mean by chemical bonding? How they are forming. We have seen the Lewis dot structure, right? Kossel and Lewis theory approach to stable electronic configuration. We have seen the octet electronic configuration. Just try to revise the structure of different molecules based on the Kossel and Lewis approach. So I hope you guys enjoy the session. There is a general reminder about the SCORE exam series. Sri Chaitanya Academy is providing an international level of scholarship examination named SCORE. The exam will be conducted on September 28 and October 12. There is a deadline to register for the examination on September 26. The link will be provided in the description. Just register now. All the grade from 3 to 12 students can attend the examination. You will be getting an excited opportunity to go for NASA trips, exciting gadgets, and up to 100% scholarship will be provided by the Sri Chaitanya Academy through this scholarship examination. So don't miss this opportunity. Link will be provided in the description. Just register now. Okay, I hope you guys enjoyed the session. If you really like the session, hit the like button, subscribe our channel, and share this particular session to your friends also. In the next class, we will be discussing about the formation of covalent bond in detail and the ionic bond formation. So, thank you so much all of you. See you in the next class. Bye-bye.